Why is the speed of light capped at 300 km/s? No one knows. There is no reason why it couldn't be any other specific value which can also be said about most other constants. Massively oversimplifying, it's not so much the speed of light as the speed limit of space, specifically of spacetime. Photons go as fast as possible, hitting the universal speed limit. This is the other way around. We have measured it. That's what it is. Because photons are massless and we have measured them to go systematically at that speed in a vacuum, and we experimentally see all particles with mass unable to reach such speeds, we developed a model that conforms to the observations. Physics cannot explain why things are the way they are. It can explain what and how much and when, some superficial whys, but no fundamental philosophical whys. You could make the speed of light 1 if you use distance at time units that make it so. Because after light speed comes ludicrous speed. The better question is, why is the speed of light causality finite instead of infinite? It just is. Arguably, if causality moved infinitely fast, then everything would just all happen at the same time, and there'd be no time to speak of. But that's more a question for philosophy than physics. Once we've established that it's finite, the value we measure it as depends on our units of measurement. Arguably, the speed of light should just be 1 and everything else should be defined relative to that. The question isn't why the speed of light is 300,000 km/s, it's why are the kilometer and second defined such that their ratio is 1,300,000th the speed of light? Because that isn't the speed of light, it is the speed of causality. Under normal circumstances, nothing can exceed it, light just isn't an exception. Even gravity has that same limit. Why that limit is there, we have no idea. Note, I'm not an expert, so that's just how I understand it. That's all the simulation's computer can handle. A single phrase explanation: if anything could travel faster than light, light would. The limitation isn't on the particle, it's in the space-time continuum. If any matter could travel faster than this limit, light would, and other particles with similar properties would too, like neutrinos. It's not that it's capped, it's that the speed doesn't change. The speed is the speed, and that value is arbitrary. It could have been higher or lower, but it would still be constant, and then we'd be asking why is it this value. As to the why, we do not have the answer. That's not to say there isn't an answer, but we don't know what the answer is, or if there even is or is not one. No one really knows. What we do know is that relative velocity and time are the same thing. There comes a point light speed where time does not tick. A light particle does not experience time. Lens to logic, if you could pass light speed, you would invent a time machine. Time dilation is weird as fuck. Perhaps this will help as you read these other answers. We call it light speed because light is the first thing we measured, but really it's the speed of causality. If a then be, it's the speed of information. Gravity, light, all info. Take the smallest possible distance in the universe, Planck distance. There is nothing smaller. It's like the pixel of the universe. Then take the smallest possible time, Planck time. There is no shorter time. Speed is distance over time, right? Well, Planck distance over Planck time equals c. Measure any two and you can calculate the other. It's something woven into the fabric of the universe itself. C is hard-coded into our universe. Reality is contained by what is observable and measurable. We can only observe light going so fast, and we have no way to measure it further beyond what we got. Therefore, we slapped a limit definition on it for lack of being able to define beyond the measurable. One day, maybe, who knows, we will embrace quantum reality a bit better. There could be all kinds of things going on we have absolutely no way to even conceptualize, therefore, or even further away from embracing or understanding it beyond science fiction or crazy talk. The way I see it is that you need more energy to go faster, and the faster you go, the more energy you need. At some point, you'll need infinite energy to do just that tiny bit faster, and that's at 9.9999 the speed of light. Light doesn't have mass, so it goes at the speed limit. The number itself doesn't mean anything. It happens to be that weird number just because we defined a second and a meter before Einstein's relativity. A good analogy would be 0K, which is minus 273.15 C, is a very weird number. But that's just because Celsius is based on water freezing and boiling point, and it was invented 150 years before Kelvin calculated absolute zero. Our three-bit problem. I'm Gilbert Tinstein, and I don't know the answer. That's what relativity is all about. One way of looking at it is that things don't move just through space, they move through spacetime. The faster you move in space, the slower you move in time. Your velocity in spacetime is always the same. When you hit the speed of light, you stop moving through time. No time passes for photons as they travel. Things just sort of fall apart if you imagine going faster than that. Some say you go backwards in time. But that's really just playing with math. It has no basis in reality. Well, the reason for speed of light is kept at c is because c is maximum speed of the universe, and any weightless particles, including photon, always travel at maximum speed. But why is c the maximum speed? Nobody knows. Religious people can claim it's designed by God. Atheists will just be honest and say we don't know. And sadly, I don't think it's even possible to know. Based on various equations, it's this number that came closest to agreeing with previous theories or proven experiments or observations. Light has never trained, so it doesn't get any faster.